I want to tell you about the worst mistake a genius ever made. And I mean the sharpest mind of his century, sitting at his desk with the truth of the entire universe written out in his own handwriting, and losing his nerve. He'd built the equation. You've spent this whole season showing me what it can do. Then starlight, dig black holes, shake the fabric, nudge the clock in my pocket. And one afternoon he did the boldest thing anyone had ever dared to do with it. He didn't feed it a star, he didn't feed it a planet, he fed it everything. The whole universe all at once in one go. And the equation answered him. It told him something so enormous that no instrument on Earth had yet seen it, and he was so frightened of the answer that he reached back into the equation and quietly changed it to make the answer go away. Years later, he called that the biggest blunder of his life. So here's the thing that's been eating at me all week. What does an equation have to say to you for the person who wrote it to be too afraid to believe it?
That is the right thing to be haunted by, and I'll give you the answer straight because it's too big to sneak up on. The equation told him the universe cannot hold still. Not does not, cannot. It told him the cosmos must be growing or it must be dying, swelling outward or falling inward, but that under no arrangement could it simply sit there the way everyone since the beginning of thought had assumed it just sat there. And that was so unlike the calm, eternal heavens everyone carries around in their heads that he decided his own equation had to be broken. So he doctored it.
He doctored it, the most beautiful thing physics owns, and he took a pencil to it.
He added a piece, a small, deliberate fudge, for one purpose only: to prop the universe up, to hold it dead still against its own weight, like slipping a matchbook under a table leg to stop it rocking. And that matchbook is the blunder, because a few years later somebody actually looked at the sky, and the universe was doing precisely what the untouched equation had said it would do all along.
So he could have called the single biggest fact about the cosmos before anyone pointed an instrument at it. It was sitting in his own arithmetic, and he flinched.
He flinched. That's the tragedy. And it's our doorway tonight, because I want to walk you up to that same equation and let you feel the thing that scared him. And I don't think you're going to want to flinch. I think you're going to want to lean in.
All right, but ease me in, because last time we spoke you had me thinking about a clock on a mountaintop and a satellite over my head. Small, homely stuff. How do we get from a clock in my pocket to the whole universe in a single breath?
We get there by being greedy. So think about what we've actually been doing all season. We've had this one equation, matter on the one side and the shape of space-time on the other, and every time we've used it, we've been polite about it. Modest. We fed it one star, and out came the geometry around that one star. We fed it a lump of collapsed matter, and out came a black hole. Two of those spiraling together, and out fell a ripple. Every single time, one object, one little patch of the cosmos, sitting alone in otherwise empty space.
One thing at a time, behave yourself, ask a small question, get a small answer.
Exactly the manners you'd hope for. And then, one day, the greedy thought arrives, and it's almost childish in its cheek. The equation takes matter and hands you back the shape of space-time. Well, what's the biggest lump of matter there is? Why keep feeding it one star at a time? Feed it all of them. Every star, every galaxy, every scrap of matter and light there is, the whole contents of creation, poured in at once, and ask what shape comes out the other side.
And the shape that comes out isn't the shape around a star anymore. It's the shape of the whole thing.
The shape of the whole thing. The geometry of the universe itself. Its size, if it has one. Its history, its fate. You've stopped asking, what does space-time do near this object? And you've started asking, what is space-time doing, everywhere, all of it, all at once? Same equation you've known all season. You just pointed at the biggest possible target and refused to look away.
But that should be hopeless, surely. To feed the whole universe in, I'd need to know where every star sits, every speck of dust, every planet. That's not a calculation, that's an inventory of God's own attic. Nobody can write that down.
And that's the first lovely trick, the one that makes it possible at all. You don't write down every star. You cheat. But you cheat honestly. You stand back, really far back, farther than a galaxy, farther than 1,000 galaxies. And from far enough away, you stop seeing the lumps. The stars blur into galaxies, the galaxies blur into a fine spray, and the spray blurs into a kind of smooth mist, an even haze of matter poured through all of space at roughly the same thickness wherever you look.
So you deliberately squint until the universe goes blurry, and then you pretend it was smooth the whole time.
That's it exactly. And it's not the swindle it sounds, because on the largest scale, the universe really is like that. Zoom out far enough, and one great patch of sky is much like another. The same faint, even scattering of galaxies. No special crowded middle, no thinned-out edge. And, this part matters, the same whichever direction you turn. There's no grand centre of town and no quiet outskirts. Just the same even filling, everywhere, every way you face.
And a smooth, even filling is a thing you can actually hand to the equation.
A thing you can actually hand to it. You don't need the attic inventory. You need one number. How thick is the mist? And the equation takes it from there. One number for the whole of creation.
That's either the most arrogant thing I've ever heard or the most elegant, and I honestly can't tell which yet.
Hold that feeling. It's both, and the fact that it's both is the whole romance of it. Now, before I tell you what came out of the equation, I need you standing in the old picture first, because you can't feel how strange the answer is until you feel how ordinary the assumption was. So, Newton. What was the universe to Newton?
A room, a great big room. Space just sitting there, going on forever in every direction, with the stars scattered through it like furniture. The room doesn't do anything. The room's just where everything happens.
A room that was there before the furniture and would be there after it. Fixed. Eternal. An empty stage with actors on it. Space the thing that never changes, so that you can measure every change against it. And time a clock in the corner, ticking the same for everyone, forever. That's the cosmos nearly everyone lived in. A still, endless hall, furnished with stars, always been there, always would be. World without end.
And I'll be honest, that's still the cosmos I live in when I'm not concentrating. The stars are up there. They've always been up there. The night sky is the one thing you'd swear on your life never moves.
Of course you would. It's the most natural picture in the world, and the whole species held it for the whole of its history. But you already know, from everything we've done, that it's built on a lie. Because the stage isn't a stage. The room bends. It has a shape, and the shape is set by what's inside it. That's been the drumbeat of the entire course. Geometry isn't the backdrop. Geometry is a player. And here's the thing nobody wanted to say out loud. If the room can bend, then the room can move.
The room can move, meaning the whole of space, the size of it, can change. That's the sentence Newton would never have let himself write.
Never in 1,000 years. And now we can finally ask the question his fixed hall forbade. Remember the deepest thing we ever said about this equation. It runs both ways. Matter tells space-time how to curve. The curved space-time turns around and tells matter how to move. So take that smooth mist of matter, filling all of space. Every scrap of it has weight. Every scrap pulls on every other scrap. That's gravity, the one thing matter never stops doing for an instant. Now let all of that matter tell all of geometry what to do. What does it say?
Ask it the plainest question then. A universe stuffed full of matter, everything pulling on everything else. Can it just hang there?
Can it just hang there? Go on, answer it. What's your gut say?
My gut says, yes, it has to. It's the universe. Where's it going to go? Everything's pulling on everything, fine, but it's pulling evenly, in every direction at once, so it all cancels. Every tug to the left is matched by a tug to the right. It's a tug of war with an equal team on every side. It stays put.
That's the trap, and it's a gorgeous one, so let me spring it. You're right that at any one spot the pulls cancel. No scrap of matter knows which way to drift, because every direction looks the same. But that was never the question. The question isn't which way. The question is whether the whole thing can be still. And to feel the difference, forget the universe for 1 second and throw a ball straight up in the air. At the very top of its arc, that one instant before it comes back down, is it holding still?
For half a heartbeat, yes. Right at the peak, it's got no speed at all. It stopped.
It stopped. But is it resting?
No, it isn't. It stopped, but it's not resting. Gravity's still got it. It's already falling. It just hasn't started moving yet. Being stopped for an instant isn't the same as sitting still. Nothing can hover. The ball can't hang up there.
Nothing can hover. And there's the season's oldest thread, the very first thing I ever handed you, coming back to close the loop. The falling feeling. Everything, from the first night to this one, has been about the plain fact that matter falls. And now you point that same iron fact at the whole universe. All that matter, pulling on all that matter. It can no more hover than your ball can hover at the top of its throw. A universe full of stuff cannot sit still for the very reason the ball can't hang in the air. Gravity simply will not allow it.
So it has to be falling. The whole universe is falling.
The whole universe is either falling together, collapsing, all that matter crashing inward on itself, everything rushing to a crush, or it was thrown, and it's still flying apart, coasting outward with gravity dragging on it the whole way, exactly the way your ball rises while it bleeds off speed. One or the other, swelling or shrinking, rising or falling. But the one answer that isn't in the deck, the one thing it flatly cannot do is nothing, still, forever the same.
And which one are we, rising or falling? Because those are very different bedtime stories.
They are, and the equation on its own won't tell you which. That part you have to go outside and read off the sky, and we're about to. But feel the shape of the thing first. Either answer is a universe with a history, a universe that was different yesterday and will be different tomorrow. A cosmos with a story instead of a stillness. That alone is the thunderbolt, and it's the thunderbolt he couldn't take.
This is the answer that scared him.
This is the one. Picture it from his side. The whole world, all of history, every poet and every priest agrees the heavens are the very image of permanence, the fixed stars, the eternal night. And his own equation, the thing he trusted more than his own eyes, slides a note across the desk that reads, "No. It's moving. It was always going to be moving. It cannot be otherwise." And that was too much. So he took the note back and wrote a new one.
The matchbook. Tell me what the matchbook actually was.
A push. He added a gentle outward push to the equation, a thing woven into space itself that shoves everything apart. And he dialed its strength to precisely the amount needed to stand off gravity's inward pull, so the two would balance and the cosmos could sit becalmed forever. And the trouble with a matchbook under a table leg is it only works if nobody breathes on the table. His balance was a knife edge. Nudge the universe a hair bigger, and his push wins and runs away with it. A hair smaller, and gravity wins and crushes it. It couldn't survive a sneeze.
a static universe held together with a wish, and he preferred that to just believing what the thing told him.
He preferred a rickety, doomed balancing act to the plain reading of his own equation, because the plain reading was simply too wild to say out loud. And then somebody looked. But before we go outside and look with them, I want you to earn the answer, so that when the sky confirms it, it lands in your chest instead of just being told to you. We've settled the universe must be moving. Say it's the flying apart one. It's swelling, getting bigger. Now sit with what that actually means, because this is the exact spot where nearly everybody's picture goes wrong, and I won't have yours be one of them.
Getting bigger. Fine. So the galaxies are all rushing away from each other, like the bits of a firework after it goes off. Shrapnel. Everything flying outward from the blast.
That, right there, is the picture I have to take away from you. Gently, but completely. Because it's wrong, and it's the single most misunderstood idea in all of physics, and its wrongness hides the whole miracle. The galaxies are not shrapnel. Nothing is flying through space. Let me build you the right picture, and once you've got it, you'll never lose it. Imagine a balloon, a plain balloon, not blown up yet, and I take a pen and dot little galaxies all over its skin. Dozens of them, freckled across the rubber. Now I start to blow it up.
And the dots spread apart.
The dots spread apart, but watch them carefully, because not one of those dots is traveling across the rubber. Every dot stays exactly where I drew it. None is crawling toward another, none is fleeing. They're pinned. And yet every single dot is getting farther from every other dot. Why?
Because the rubber between them is growing. The dots aren't moving. The skin they're stuck to is stretching, so they get carried apart without ever taking a step.
Without ever taking a single step. And that's the whole thing, that one sentence. The galaxies aren't flying apart through space. Space itself is swelling, and the galaxies are just going along for the ride, stuck in place while the room between them grows. It isn't the furniture sliding across the floor, it's the floor itself being woven wider, everywhere at once, and the furniture riding out on it.
So my firework was exactly backwards. There's no blast throwing things outward. The thing sits still, and the emptiness between them manufactures more of itself.
Manufactures more of itself everywhere, all the time. And here's a way to say it that ought to ring a bell from the night we talked about the metric. The ruler. The distance between two galaxies grows not because they row apart, but because the very ruler that measures the gap between them is lengthening. The yardstick of space itself is getting longer. Nobody moves, and yet everybody ends up farther away.
The ruler itself grows. That's a much more unsettling sentence than things move apart. And I think it's the true one.
It's the true one. And now feel the next thing, because this is where the balloon earns its keep. You're a dot on that balloon. Look around at your neighbours. The dots nearest you drift off slowly because there's only a little rubber between you and them to stretch. But a dot way over on the far side has a huge stretch of rubber between you, and all of it is growing at once, so that far dot goes racing away much faster. The farther the dot, the faster it flees you. The near ones amble, the far ones bolt.
More rubber in between, more stretching adding up, so the distant ones pull away quicker. And I take it that's not just a pretty picture, that's what somebody actually saw.
That's exactly what somebody saw when they finally turned an instrument on the far galaxies and asked how they were moving. The nearby ones drifting away gently, the distant ones racing away hard. And the farther out they looked, the faster the galaxies were fleeing, in the plain, particular pattern of stretching rubber, of a thing swelling evenly from the inside. The sky was a balloon being blown up, and we were a dot on it, watching every other dot pull away.
Hold on though, if every galaxy is rushing away from us, near ones slow, far ones fast, everything fleeing, then aren't we the dot in the middle? Doesn't that put us smack at the center of the whole thing? Are you about to tell me we're the belly button of the universe?
I love that you asked, because it's the perfect trap and the balloon springs you clean out of it. Go back to the balloon and be a different dot. Any dot you like, over on the side. Look around from there. What do you see?
I see. The same thing. Every other dot pulling away from me. The near ones slow, the far ones fast. It looks exactly the same from wherever I stand.
Exactly the same from every dot. Every single dot on that balloon is convinced it's the still center, and everyone else is fleeing it. And every one of them is equally right and equally wrong. Run your finger over the whole skin and try to find the one spot the expansion happens around. You can't. It isn't happening around any spot. It's happening at every spot. The center of the expansion isn't somewhere on the balloon. It's nowhere on the balloon because the expansion has no center.
So we look like the middle of everything, only because everybody, everywhere, looks like the middle of everything. There's a creature on the farthest galaxy we can see, right now, certain that we're the ones fleeing, and they're the still point the cosmos turns around.
And that creature is exactly as right as you are, which is to say, not at all. Nobody's at the center because there is no center. Now, I'll ask you to be brave, because you're about to reach for the obvious thing. You're going to point at the middle of the balloon, the actual center of the ball. Surely that's the center.
I was, yes. The middle of the rubber ball. The air inside it. That's got to be the center of the whole business.
And this is the one place the balloon can lie to you, so don't picture it. The rubber skin is the whole of space in this story. That surface is standing in for all of our space. The inside of the balloon, the outside of it, the air you'd blow into it, none of that is real. None of it is part of the world. There's no middle of the ball, where it all began, and there's no outside the ball for it to expand into. There is only the skin, and the skin is everything there is, and the skin is getting bigger without there being anywhere it's getting bigger into.
Now you've done it. Now my head hurts in the good way. Getting bigger without there being anywhere to get bigger into. That's the sentence that shouldn't be allowed.
And yet, it's the truest thing about the whole business. And look, you've met this exact idea before. We just didn't call it home. Cast your mind back to the ant. The ant on the curved surface, weeks ago, who could measure the curve of her whole world from the inside without ever leaving it, without there needing to be any outside for her surface to curve into. Same trick, worn a different way. Space doesn't need an outside in order to be curved, and space doesn't need an outside in order to grow.
The growing is a thing you measure from within, not the universe getting bigger inside some larger room, just the distances, all of them getting longer.
Just the distances getting longer, measured from within, needing no bigger room to happen in. The universe isn't expanding into anything, it's simply expanding, and that is the whole and entire fact of it. Now, you've been patient, so let's go outside and actually catch it, because you keep letting me say they looked, and I owe you how you clock the speed of a thing that far away.
I do want that, because you can't exactly chase a galaxy with a stopwatch. How do you read it?
You read its light, and this is the loveliest part, and also, I'll warn you, the part the whole world gets wrong, including people who ought to know better, so we'll do it properly. Light comes in colors, and color is really just the length of the wave. The little crests of the light marching along and how far apart they sit. Crests bunched tight, toward the blue end. Crests spread out long and lazy, toward the red end. Color is a wavelength wearing a disguise.
Tight crests blue, stretched crests red. Fine, I'm with you. And what does the far light actually do?
It comes in shifted toward the red, dead consistent. Its crests arrive stretched out longer than they left, and, the very pattern from the balloon, The farther the galaxy, the redder its light. The most distant ones we can find have had their light stretched the most. Now, your first instinct is going to be to explain that the way you'd explain a passing siren.
The siren, yes. The ambulance comes at you, high whine. It goes past and races off and the whine sags low. Because it's rushing away, the sound stretches out behind it, lower. So, galaxy rushing away, light stretched, redder. Same thing. Except I can hear from how patiently you're sitting there that it isn't the same thing at all.
It isn't, and it's so nearly right that it's fooled 100 years of people, so don't feel a thing about reaching for it. Here's the difference, and it's everything. The siren stretches because the ambulance is genuinely moving through the air, charging across the street, physically travelling, leaving each sound crest behind it from a little farther back. That's a thing barreling through its medium. But the far galaxy, back to the balloon, is a dot pinned to the rubber. It's sitting still. So what stretched its light?
The rubber, the space in between. The light left the galaxy, and while it was crossing all that distance to get here, the distance itself grew.
The distance itself grew, while the light was in flight. That's it. That's the whole miracle, and it's a completely different animal from the siren. Draw a wave on the skin of the balloon before you blow it up. Crests marching along the rubber. Now inflate the balloon. What happens to your drawn-on wave?
It stretches with everything else. The rubber grows, so the wave painted on it grows too. The crests get dragged farther apart. The wave gets longer just from riding on the stretching skin.
Longer just from riding on the stretching skin, and that is exactly what happens to the light. It leaves the far galaxy with its crests a certain distance apart, then spends an enormous span of time crossing space to reach us, and all through that crossing, the space it's travelling across is swelling, and the light, riding on that space, gets stretched right along with it. Every crest dragged farther from the last. It arrives with its wave pulled long, reddened, not because the galaxy fled through space, because the space the light was swimming in got bigger underneath it the whole way here.
So the redness isn't a report on how fast the galaxy is moving, it's a report on how much space swelled while the light was on the road.
That is the single most important sentence you'll say tonight, and you got there yourself. The redness measures how much the universe grew during the light's journey. And now, farther is redder falls out like a gift. Light from a more distant galaxy spent longer on the road, so more swelling happened underneath it, so it got stretched more, so it comes in redder. The distance and the redness march together because they are the same fact, told twice.
And this light's been travelling so long that it left when the whole universe was smaller than it is now. It's carrying the expansion written right into it. It's not a Doppler whine of something speeding off, it's a photograph of space getting bigger, developed slowly over the whole trip.
A photograph of space getting bigger, developed on the way. I couldn't say it better, and I shan't try. And this is the very piece he could have called before anyone looked. The untouched equation said the universe grows. A growing universe stretches the light crossing it. Stretched light comes in red. Farther light comes in redder. All of it sitting in the arithmetic, years before a single galaxy was clocked. So when somebody finally read the red in the far light and watched it climb steadily with distance,
they weren't discovering a surprise, they were catching the universe in the act the equation had already described. And that's when the matchbook comes out from under the table leg.
That's when. The push he'd invented to hold everything still had never been needed. The universe was never trying to hold still. He pulled his little piece back out of the equation, and by every account he was mortified. And that's when he called it the blunder of his life. Now, I'll say one thing once and lightly, because it's a tale for another season entirely. That discarded piece of his has had a stranger afterlife than anyone at the time could have dreamed. But leave that be. Tonight it's simply the blunder, and the lesson in it is the one worth keeping. Trust the equation over your comfort. He didn't once, and it cost him the greatest prediction in the history of science.
Right, so the universe is swelling, every distance stretching, the galaxies riding apart, the light reddening on the way. Now do the thing I can feel you've been saving all night. Run it backwards.
Now we run the film backwards, and this is where a rather dry fact about geometry turns, without warning, into the most dramatic story ever told. If the universe is bigger today than it was yesterday, and bigger yesterday than the day before, then walk it the other way. Yesterday smaller, everything a little closer together. Last year closer still. Keep winding the reel and the galaxies crowd in toward each other. The mist of matter thickens, every distance shrinks, and everything you can see packs nearer and nearer to everything else.
Rewind the balloon and it deflates. The dots come home toward each other, and I feel like something happens to all that crammed together matter that's more than just, it's crowded now.
Something does. When you squeeze matter together, it heats up. Cram anything into a smaller space and it gets hotter, as true of the whole universe as of a bicycle pump warming in your hand. So wind the film back and the universe doesn't only get denser, it gets hotter. Denser and hotter, denser and hotter, the deeper into the past you go, until the galaxies themselves can't survive it. They melt back into loose matter, and the matter is crushed and cooked until the whole universe, every part of it, is a single blinding, seething blaze.
No stars, no galaxies, just fire, everywhere, edge to edge.
Fire everywhere, edge to edge, packed to a heat and a density there are no words homely enough for. And that, of course, is where this whole night has been walking. That's the Big Bang.
And I can feel my firework coming back to charge at me, worse than before. A bomb. A firecracker going off in a great, dark, empty hall, blasting matter out into the room around it. That's fully formed in my head, and has been since I was small. Where's it wrong this time?
It's wrong in the same way the shrapnel was wrong, grown to its full and terrible size. In the firecracker picture, there's a hall, a great dark, empty space, sitting there ready, and the bang happens at one spot inside it, and the debris flies out to fill the rest of the room. But there is no hall. Go back to everything we've built. The bang is not a thing that happened at one spot in space. The bang is space. It's the whole balloon, when the balloon was shrunk to almost nothing, every dot on it crammed together because there was hardly any rubber between them yet.
So there's no empty room around it for the debris to fly into. The room is the thing that's blazing.
The room is the thing that's blazing. The bang wasn't an explosion in space. It was the fierce, hot beginning of space itself swelling, and it happened everywhere in space at once. So ask, where did the Big Bang happen? And the honest answer is, here, and also there, and also every single place you could ever point.
Here, as in this room. I can't point up at the sky and say, the flash was over there.
You can't point at it, and this is the part that gives me chills every time I say it. It happened in the spot where you're sitting right now, and in the middle of the farthest galaxy, and in the empty dark between the stars. All of it, the same event. You are not sitting at a safe distance from where the Big Bang was. You are sitting inside where it was. Everywhere is where it was, because back then, everywhere was the same place.
Everywhere was the same place. I have to stop and hold that because it's doing something to the floor. The place it happened isn't a place I could travel to. It's the place I already am. It's every place.
Every place, when every place was one place. And there's no edge to it either, for the same reason there was no center. You can't fly to the outer wall of the universe and watch the expansion from beyond the fence, because there's no fence and there's no beyond. It's the balloon again. No center on the skin, no edge to the skin, nothing outside for it to sit in. The Big Bang has no address. It's not a where, it's a when. The earliest moment, the instant the growing started. And every part of the universe, this room included, was there for it.
A when, not a where. The beginning wasn't a place in the universe, it was the beginning of the universe. The whole thing, all at once.
Now you're speaking it like a native. And here's the gift the whole picture hands us. The thing that turns it from a lovely story into hard science you can catch red-handed. If the early universe was a furnace, packed and blazing edge to edge, then it was flooded with light. A fire is full of light. A universe-sized fire is full of a universe of light. That light was trapped in the blaze, sloshing about in the fierce, hot crush of it. And then the universe kept swelling, and as it grew, it thinned and it cooled. The fire spread itself thinner across more and more space, and it faded the way any fire dies down as it spreads.
And the light that was trapped in the fire, where does that go? It can't leave. There's no outside.
It's still here. That's the staggering part, that light never left, because where would it go? It's still crossing the universe this very second. But it's been riding the swelling space for the entire history of everything, the longest journey there is, so it's been stretched. The same balloon stretch, the same reddening, but stretched further than any light from any galaxy. Stretched so far past red that your eye can't catch it at all anymore. Pulled all the way down from blazing firelight to a faint, cold whisper. And it's arriving, right now, from every direction of the sky at once.
The light of the fire is still in the room. Cooled down to almost nothing, stretched out over the whole age of the universe, but still coming in from everywhere.
From everywhere, because the fire was everywhere. That even hum of warmth soaking in from all around us is the afterglow of the beginning. The cooled, stretched, faded light of that first furnace still washing over us after a journey as old as time itself. It's the oldest light there is. Nothing has ever traveled longer to reach you. And we can catch it. We built instruments patient enough to feel that whisper of warmth. And when they listen to the sky, there it is. The same faint heat in every direction. The embers of the Big Bang still glowing.
We can actually detect the leftover heat of the beginning of the universe. I want to be cool about that, and I simply can't. That's the afterglow of creation, arriving in the mail, every second, on time.
Every second, on time. And here's the part that should raise the hair on your arm. This faint, even warmth was predicted before it was found. People reasoned, from exactly the story we just told, that if the universe began hot, it must still be aglow with the cooled remains of that heat. And then somebody listened and found the glow, humming in from all sides, just as the story required. That's when the whole thing stopped being a beautiful story and became the history of the world.
So lay the thread out for me, end to end, because I want to feel the whole length of it at once.
The whole length of it. The same equation that nudges the clock on a satellite told us the universe must move. The moving universe stretches the starlight red. The red starlight, wound backwards, gives us the furnace. And the furnace left an afterglow we can still feel on our faces today. One thread, from a falling apple all the way to the birth of everything.
From a falling apple to the birth of everything. When you line it up like that, it stops sounding like physics. It sounds like the universe telling its own life story, and using your equation as the alphabet.
And that's the wonder I want you to carry out of here. The very same geometry we started this course with, the shape of space-time, the falling feeling, the bending of the room. When you're bold enough to point it at everything at once, it doesn't shrug and go quiet. It hands you the biography of the cosmos, the birth, the fire, the long swelling, the afterglow. The thing you learn by watching an apple drop turns out to have written the history of all creation.
So is that it? Is the universe solved? Because you've got the look of a man about to take something away from me. You always get that look right when I'm at my very happiest.
I do have to take something, and I'd be lying to you if I didn't. Here's the honest boundary, and I won't let you leave without it. Everything we did tonight tells you that the universe expands, and that it was once hot and dense, and how it's behaved ever since. What none of it tells you, not one word, is what banged, or why. The equation runs the film backwards beautifully, but it never explains the first frame. It doesn't tell you what lit the fire, or where the matter came from, or why there's a universe here at all instead of nothing.
So it answers what happened and stays honestly quiet on why anything. I can live in that, but you said take something, singular, and I've only counted one. There's a second hand behind your back.
There is, and this one isn't modesty. It's a wound. Come back to the film running backwards, and this time let's not be gentle with it. We wound it back to the furnace, everything crushed and blazing, and I stopped the reel there to keep it bearable. Don't stop it. Keep winding. The universe gets smaller and hotter and denser, so keep going. Smaller, hotter, denser. What's it heading toward? Follow it all the way down and don't flinch.
It keeps shrinking. Everything gets closer and closer together. The distances between everything getting smaller and smaller, down toward no distance at all. Everything in the same place. And if everything's crammed into no space, then the amount of stuff packed into each scrap of space,
Say it.
it goes to infinite. The density runs clean off the end. You can't cram everything into nothing without the crowding going to... There's no number for it. It just breaks.
It runs off the end. And that, right there, at the very first instant, is the equation putting its hands up. Because infinite density is not an answer. It's not a description of a place or a thing. It is the sound an equation makes when it breaks. Wind the whole universe back to that first instant and the beautiful equation, the one that bent starlight and dug black holes and wrote the cosmos's whole biography, stops giving you a hot, dense something and starts screaming a nonsense infinity. And that scream means one thing, and one thing only. I have reached the edge of what I know. Do not trust me here.
So the theory that describes the entire universe can't describe the one moment that matters most, its own beginning. It works all the way back to the fire, and then, at the very first instant, it hands you an infinity and quits.
It hands you an infinity and quits. And if you've been listening all season, that word should ring a bell. Because it isn't the first time we've heard the theory scream.
The middle of a black hole, right at the center. You said the numbers went mad there too, and that we'd come back to it. Same scream.
The same scream in two different corners of reality, deep in the heart of every black hole and at the very birth of everything. Two places where general relativity, the most successful idea we have ever had, looks at what it is predicting and admits it cannot be the final word. And that's where I have to leave you tonight. Not on the tidy triumph you wanted, but on something better. A theory great enough to write the whole history of the cosmos, and honest enough to point at the two spots where it falls apart and say, past here, I don't know. Somebody else will have to finish this.
And you're doing the thing again, aren't you? Hands in your pockets, not reaching for the floor. Last time you left me standing in wreckage, it was the finest trap ever built coming home empty. This time it's the finest theory ever written, running the whole universe backwards flawlessly, right up until the first instant, and then, at the one moment I most want an answer, it just stops. Predicts infinity, tells me not to trust it, and I can tell from your face there's nobody at the end of this corridor with the fix already in their coat pocket. Not yet.
Not yet. And maybe that's the most honest and the most thrilling place a course like this can end. Not on the answer, but on the exact shape of the question that's still open. The universe expands. It began in fire. It still glows with the embers, and its own equation, wound back to the very start, breaks in our hands and tells us there is one more thing, deeper than all of it, that we do not yet understand. That isn't a failure. That's an invitation.
Then that's the one I'll carry up the stairs. Not the fire, not even the afterglow humming in from every side, but the crack. The place where the most beautiful equation ever written runs all the way back to the beginning of everything, hits the very first instant, and quietly admits it can't go on. I came down here tonight thinking the universe was a room the stars sit in. I'm going back up knowing it's a thing that grows, a thing that remembers its own birth in the leftover warmth of the sky, and that somewhere at the bottom of that birth is a scream of infinity that means our finest map of reality has an edge, and the edge is right at the beginning. So, next time, what lies past the edge? What can be said about the first instant, the true first instant, once general relativity has thrown up its hands and walked away? Good night.